So in the last few chapters, we looked at creating lofts and then how to control them, how to define whether they smooth along their length, whether they've got mapping, how the mapping tiles, how the tessellation works both along the U and the V of the actual loft surface. What we're going to look at in this chapter is the set of deformation tools that come along with the loft. And they're actually pretty complex. They use a kind of unified tool set, and that set of deformations actually is based on splines themselves. So you can get an idea now where splines are not only used for modeling in 3ds Max, but they're used in various places in the user interface to carry out both animation, deformations, and so on. So anyway, to show you these tools, what we need first is a loft. So I'm just going to create a loft here. Go to create objects, compound objects, and click on loft. We've already got the path selected, so now we have a proto loft surface, as you know from the earlier chapters. We just need to give it a shape. So I've got instance turned on, get shape. Just going to pick this rectangle. And you can see immediately we've got a problem, and that's because the shape is actually at 90 degrees to what I wanted it to be. I actually wanted it to be quite thin along here, so we really need to rotate this through 90 degrees. So if I go into subobject mode, this is actually the easiest way to fix this. And once I've selected that shape, as you can see down the end there, I can now rotate it. If you look at this angle here, you'll see that as I rotate it, I've got snaps turned on. So it's just snapping to 5-degree increments. So I can get it to 90 degrees. Oops. I just got to the edge of the screen there, so let me just try that again. So I can get it to 90 degrees, leave go, and we've got the shape that I actually originally wanted. The other way of doing it is by actually getting the original spline and modifying that in place, which is something which is also perfectly valid. And because we have a dynamic relationship between these two objects, this will actually update to take into account any changes here. So you see, I've got an edit spline modifier on this rectangle. So I can go into subobject mode, select all of these vertices, and I've got rotation mode turned on. And you can see what it's going to try and do at the moment is it's going to actually try and rotate the vertices themselves around their own axes, which doesn't really make any sense. So what we need to do is we need to say parent. Let's say parent there, and we're going to say use this particular option, which you remember from DVD1 is the use transform coordinate center rollout, so we can choose where our coordinate center is. Now we're using parent, and the parent of these vertices is the object itself, and the pivot point of the object is right here. So now when we select these, we can actually rotate them around the parent's pivot point. So now I can just rotate, say, through 90 degrees, leave go. We've got the same modification, just done a different way. So you can see that you can actually make that fix in, one or two different ways. It doesn't really make that much of a difference which way you want to do it. And in some circumstances, doing it this way may make sense. And in others, doing it the way I just showed you, by modifying the spline, may actually be the best option for you. So anyway, here we go. We now have our loft, and now I can carry out some deformations on it. So if we look over here, we have the deformations, and each one of these has an activation button with its name on it. And this basically, if you click on this button, it activates that particular modification, but it also turns it on here. And you can actually turn off the deformation if you don't want to have it active. When you turn it off, you're not actually destroying the definition of the deformation here. That stays in place. You're just deactivating it. So that's what you're doing with each one of these buttons. You can see that as I turn them on, they're not actually doing anything at the moment. And that's because we haven't actually defined any of the deformations. So let me show you the user interface for scale. All of the user interfaces for the deformations are basically very similar. They use this kind of graph that you can see here. What this graph represents is along this axis, left to right, we've got the length of the path. So you can see over here we've got 0, and it goes all the way up to 100% along the length of the path here. Then we have the units of deformation. In the middle, we have 0. And in some of the deformations, the base spline that you can see here, if you can imagine at the moment this is a linear spline, that in some cases may actually lie on the 0 point. In this case it lies on 100, and that's because that makes the most sense for this particular deformation. This deformation is a scale, so by default the object has a 100% scale at both ends. And you can see that's represented by this graph here. So in other words, that means there is actually no scaling, there's no deformation on it. If we wanted to, we can modify this curve here. And when we do so, we then scale the object. So let me just show you that in action. If I just reduce the size of this, I can actually show the line here just by clicking on these options here. These actually scale the graph to actually fit inside the window in different ways. If you look at the animation features in 3ds Max, you'll actually see these are documented. This actually allows you to scale just on this axis, as you can see. This allows you to do it vertically. This does both. And this tries to actually fit whatever it is that you're working on within the window. So you can use these to basically move around the graph if you need to. And in certain circumstances, you will need that. So get familiar with those. And along the top toolbar area of the graph, you can see we've got these particular icons which allow us to do various things. And again, these are also, they tend to be consistent from one deformation to another. So let me run you very quickly through what they do, and then we'll actually make a modification. The first one is that this graph is by default symmetrical, and that means that on the x-axis and the y-axis of this loft, the deformations will be symmetrical. You can turn that off by clicking on this button, and when you do so, now you have the option of modifying two different graphs. As you can see, you've got a red graph and a green graph. So as you can see, that's the y-axis and the x-axis. You can also, if you want to, display both at the same time by clicking on that button. So let's just go back to the X graph, turn that back on. Here you can see you have the option to swap over the deform curve. So if you find that you've made a non-symmetrical deformation and you prefer to be swapped around, then you can actually just click on that and that'll very quickly change around the two curves. Then we have move the control points, and as we saw with splines earlier in this DVD, these are the control points here and here, if you can think of them as vertices basically. And if we click on here, we can select them and we can move them. You can also limit that movement to left to right and up and down. And also, you can also scale using this option here. So that should actually just scale along this axis here. Then you can add control points using this button here. And there are two types. There are corner and there are Bezier. So you can basically put in a sharp change or you can have a curvy change. Also, you can select the control point and delete it if you wish to. And the last option here resets the curve to its default value. So having said that, let's try and make a deformation. We'll grab this point here and we'll just pull it down slightly. And as we move it down, we're changing the scale at one end of the loft. And as we pull it down, we're changing the percentage, which you can see here. So it's actually lower. So let's pull it down further. And I need to actually turn this on for this to have any effect in the viewport. So let's just pull it down more. And you can see exactly what's happening. It's getting scaled in both axes at the same time along its length. As you can see, so it's both an X and a Y scale. And let's say we wanted this to be curved. We can just right click on this control point. At the moment it's a corner, but we could change it to Bezier. And because it's at the end, the only option is a Bezier corner because it can't be curved because there's no out curve for it. It just basically ends at this point. So the only option is corner or Bezier corner. But now we can actually modify. Let me just go here because I was trying to scale that curve actually rather than moving it. And now I can actually move this to here and I can do the same up here. Let's say Bezier corner and let's say we change the curve like this. So now you can see we've got this scaling going on along the length of the path. It's symmetrical in both axes. So if you look along here, we've got the same thing going on in this direction and also in this direction. But it's actually curved. And let's say we wanted to add some more definition in the middle there. We could say insert a corner point here and here. And now we can modify these. So if we click on here, at the moment it's just a corner, so we don't have any control of the curves. And because of this handle here, this actually can't be as close to here as I'd put it, so it's snapped it up here. But I could actually make this smaller. And now if I want to actually, I can move this down here. And I think that's the maximum, yeah. So I can't go beyond this handle, as you can see. But now we can actually modify the curve using these values. So as you can see, we can create quite complex shapes in this way. And if we wanted to, we can just select these, change to Bezier smooth or Bezier corners, and edit them further and as needed. So as you can see, that's a scale deformation. We can turn off symmetrical, and now I can choose to see either of the scales. So let's say on this axis, we want to get rid of this. And now we just put this up here. So as you can see now, we're just keeping the scale to one axis. If I change that axis, you can actually see that scale. And as I said earlier, if you turn on this button, you can actually see it both at the same time. You can modify both, as you can see. Let me just turn on wireframe for you, and let's just make some more deformations here. Just bunch this up a little bit. What you can see is as well is that this is something that we looked at earlier in the DVD. Because we have adaptive path steps turned on, as we increase the curvature in this area, you'll see that 3ds Max is actually putting in more steps at these points to actually allow that curvature not to become low in quality. And you can see as we spread things out, it drops the number of steps overall in that area, but still keeps the relative quality up. So I think this is a good place where you can actually see the adaptive path steps in action. If I turn that off, you can see it just uses uniform steps along the length. So depending what you're working with, this is where, adaptive step starts to show its mettle. And if we're not happy with the deformation, we can just turn it off here. Or if you want to, you can just go here and click Reset Curves, and that's done both curves at the same time. Let me just undo that. Do one curve at a time. So there you go. If you have just one curve selected, it'll just reset that particular curve. It doesn't do both at once. If you have both selected, it'll do both. And if you have them set to being symmetrical, that effectively locks the two together anyway. So clicking on that button will do both axes at the same time. Later in this DVD, we'll have a look at splines in animation. And we'll actually return to this tool, and I'll show you how you can carry out a neat trick using it to actually perform a sort of animated function. So that'll show you that the deformations in here can actually be used to carry out animation features as well as just modeling features. So it's a really flexible tool. And the interesting thing is each one of these control points can actually be animated. So let's move on and look at the twist deformation. So we'll just make sure that scale is turned off for now, because we don't want to see two deformations at the same time. Let's turn on twist. And if you look in here, we have a similar kind of graph again, as I said. Where it can, it tries to use the same conventions from graph to graph. You'll notice now, though, the curve is actually in the middle, and that's because now the vertical axis doesn't represent a percentage of scale. It actually represents degrees of rotation around the center axis. So let me just make this a little bit smaller so we can see our actual loft shape. And what we're doing now is if we modify these points, we're changing the rotation of the shape around the axis at that point. So let me just do this and you can see exactly how it works. I think it's quite obvious, really. So now I've rotated this endpoint here through, if you look at the value, 99 degrees. And if you want to, you can always type in values here. And that also goes for position, because this value is the position along the graph, and this value is the actual deformation. So let's say we insert a point. Let's go for a Bezier, and we'll put it here. We'll just change these handles so they're a little bit smaller, and I can just move this up here, say. Now you can see that at this point, it's 63.9 along the length. We could change it to 60, and just type that in. And we could change that to a little bit more precise of a value if we needed to. So, you can edit it just by typing in. You don't have to edit it here in the graph. You've got the same controls as before. You can edit these curves as much as you want, as you can see. Sometimes you may find that if you do too much of a deformation, you get this kind of effect where the shape crashes into itself some. So it's a good idea not to have anything too strong with certain deformations. But if this is what you're looking for, then so be it. That can be the kind of deformation that you want. So if you want to, you can just put in some really extreme values there. And once again, you can see you have all of these controls up here. You can just move along just the horizontal axis, or you can just move along the vertical axis. We can, and that actually goes for the control handles too. If you look, I'm actually locked vertically, can't change horizontally with this. So you can see that I'm locked on the control handles and not just on the control points. And if you want to, you can change this. You can insert any type. You can insert a corner, or you can insert a curve. And you can also change the type by right-clicking on here and saying corner, or saying Bezier smooth, or saying Bezier corner. So basically, we've got the same kind of options again here. And I can just select them, press delete on the keyboard. That will get rid of the control points. If you want to go back to where you were before. And you can go in the opposite direction as well. You can have negative rotations. And you can rotate as much as you want. There's no real limit on it. You know, you could grab this value here and say along its length rotates through 360 degrees. There you are. Or you could say rotate through minus 360 degrees, or 180, or whatever it is that you want. And you can change both ends. It's totally flexible in that respect. You'll notice that we don't have two different graphs in this particular case, because that doesn't really make any sense. We're only rotating along a single axis, not two axes. So in this case, we only have one graph. So that's it, I think, for the twist deformation. I think you get how that works. Let's move on and look at theta. Just close down this graph, and we'll turn off the twist. We'll turn on theta. So theta's kind of related to twist, and I'll show you what it does just by demonstrating. If I grab this and move this, you can see that as I do so. If you look at the shape along the path, you can see it's actually teetering. In other words, it's moving on its axis, but instead of rotating around its axis, actually it's teetering forward. So we'll just reduce this. We can go the opposite direction as well. Let's go like that. Now, by default, you can see it's doing that on both axes at the same time. So I'll just put this back to 0 here, and I'll turn off it being symmetrical, and we'll just make a modification on the x-axis first. So you can see now that it's actually teetering just along this axis here. So if you can imagine, it's rotating along an axis that runs along here. So we're making it theta in that direction. We can obviously go the opposite way too. And I'll just put that back to 0. And now if I show you on the y-axis, we'll do the same thing. Now what it does is, instead of teetering along this axis, it teeters along this axis here. So again, it's easy if we just do it. You can see exactly what it's doing then. So you can see it's pulling it towards us at the end here. We can go the opposite direction. There you go. And I think by default this tool is symmetrical. And I think when it's symmetrical, it doesn't really make that much sense, to be honest. So if you're going to use theta, probably the first thing you want to do is turn off the make symmetrical button and make sure that you're putting the theta on the axis that's good for you, for your particular deformation. Again, we have the same options as before, all the same sort of navigation tools here for zooming and framing and so on. And we've got the same tools as before also for modifying our path, swapping over the deformation curves, so on and so forth. So again, we've got the same kind of unified interface. Makes it nice and easy to use. So experiment with theta and see what you think of that. And now we'll have a look at bevel. So let's just shut down here, turn off theta. And bevel's an interesting tool. It is something which in some ways could be superseded these days by polymodeling, and this is something that we'll come to in DVD4 in this series, where when you've produced a loft surface, it doesn't have to be the end of the road. You don't have to produce every single facet of the loft the end surface that you want to produce in the loft tool itself. Later on, you can modify it using polymodeling. And it could be said that with polymodeling, you'd have a finer control over how exactly you bevel the object. I'd probably subscribe to that view. But the loft tool does actually have a bevel feature built in, so I'll show you how that works. And what we'll do is we won't bevel lots of parts of it, we'll just do the end of it here. So I'll just turn on bevel, and you can see it's got a new button here, which wasn't a feature of the other tools. It's specific to this particular tool. And again, you'll see that it isn't split up. You can't actually do it on X and Y. It only makes sense on both axes at the same time. Although I must say, to be honest, that if you could, as it were, link the points where the bevel take place, but the amount could be changed per axis, that actually would be useful. And again, this is something that you could do with polymodeling. So again, polymodeling might make more sense. But basically what bevel does is it puts a bevel on the ends of the shape or anywhere along its length really. So we need to put in a point here. So I'll go for a corner point. So I'll just put it here. You can see it's actually put the bevel down this end. And again, because we've got adaptive steps turned on at that point, because we've added that bevel, it's detected the changing curvature and the fact that it needs to add more detail, and it's put all of these edges in here. You can see it's become very, very super dense in terms of the edges here. It doesn't really make any sense at this moment because there isn't actually any deformation, but it does mean that it will actually support the deformation when we do so. I'm just going to select this endpoint here, and I'm going to change it to 2. And you can see immediately we have a bevel. As you can see, it's the same kind of value in both directions. I'll just turn off wireframe for a moment so you can see that. And we can change that again. Let's say 6. When we've gone to 6, it's actually gone to the point where it's actually overlapped these two edges, so that doesn't really make any sense. Try 4. In this particular shape, 4 seems to be about the most we can do so. And another thing is the actual shape of this here can be controlled using this button. You can see we've got a normal bevel, a linear bevel, or we've got a cubic bevel. And you can try out those different options to see if it gives you a better shape for what you're after. And the other thing is as well is that this curve between here and here also controls the bevel. So I would probably go for linear, which means just that it tries to interpolate between here and here in a very linear manner. It doesn't try and do any sort of curvature. And I would control the curvature by actually using the spline shape here itself. So at the moment we're very, very far out and we can't really see any detail in here. So what we need to do is just create a little zoom in on here. So now we can see clearly what we're doing. And also you can, scale in this direction, or in this case we want to scale in this direction. So we can see a little bit more detail in our graph. I'm just going to move this down here. And now if I wanted to, I could say right click, Bezier corner. We've got Bezier control points. And now I can modify this graph. And as you can see, we've got a curve here. And I could do the same here as well. I could move in the opposite direction here. We get this nice curve going on. Or I could go here and have it so it rounds off at the ends there. So you can see it's not a bad feature. It's pretty cool. Now, if you're going to try and do any kind of curvature like this, then it does actually have a place, I think. So you can make these kind of deformations. I find that if you try and use it in the middle of a shape, it can be problematical. So be careful in that respect. But overall, it's actually pretty cool as a tool. Let's say we could bevel the other end, put in a point here. We could just move this up here slightly. So as you can see, we need to increase this quite a bit to actually get a noticeable bevel. And I bevel both ends. And if I wanted to, I could put a bevel in the middle here. I could just add 3 points. Say like that. And don't forget, what I've done here is I've scaled the vertical axis, so we're getting a lot more detail, which for the bevel tool actually makes more sense, I think. So now I can bevel this in if wanted. And if I like that, but I want it to be a lot tighter, the best thing to do is actually use type-ins rather than editing in this respect, because it can be a little bit imprecise. So let's say the position here is 48, so we go for 48, type in 48. And we'll go for this being 48.5. And we'll go for this being 49. So now you've got a much tighter bevel in there at that point, as you can see. And if we wanted to, we could edit those curves and make it a little bit more detailed or curvy at that point, whatever we wanted really. So again, an interesting feature. We'll just turn that off and we'll look at the last option, fit. Which is actually quite different from everything else really. Because what fit does is it tries to get a spline and use that spline to define the profile of this loft. So what we need to do, we need to create a profile. So I'm just going to copy this rectangle to here. And I'm going to get the pivot and just center it in case that has any effect on our profile. And what I'm going to do now is I'm going to go in and modify these Beziers. I'm just going to make this go out like this and like this. I'm just going to pull these in so we get a kind of fishtail thing going on. Let's cross it so it's a little bit more extreme. So this is a profile, as you can see. And I'm just going to move this over here, and I'm going to make another profile. So we're just going to copy that. We don't want it to be an instance of each other. We want them to be different. And what I'm going to do is I'm going to come in and I'm going to refine. So I'm going to put in a control point here and here. And I'm just going to say, let's just make this like this. I'm going to move these out so they're going in the opposite direction. Just have a look at those. They're not really symmetrical at the moment, are they? So let me just modify this slightly. There we are. So now I think we've got two reasonably different profiles, and I think we can use those separately. So now we have those, we can go in here and say fit, and it brings up this dialog here. And you can see we have two different axes in this particular case, so we have the symmetrical buttons working again. And in this case, I'm just going to say, let's have it so it's symmetrical. And I'm going to go over here and I'm going to say get a shape. This is what this button does here. You can see this deletes shape if needed. So I'm going to pick this one here. And you can see that what it's done is it's kind of confined the shape to this profile here. And this profile doesn't have to be symmetrical if I wanted to. Let me just grab here. I can change this so you can see what I mean. We could go like that. And now if we wanted to, go back in here, open up the dialog and pick that shape. As you can see, it's not a dynamic link in this particular case. You have to repick it. But once you have actually picked it, you can see that in here, you can modify it. So you can actually edit it in place. So this shape here is just basically a template for it to actually give it a start in terms of defining a shape in here, as you can see. Or we can pick that shape again. And if we want to, we can just click off here, put that back to where it was previously. There we are. And I'll just go back in here and pick that shape up once again. And as I said, it doesn't have to be symmetrical, so you can turn this off. Currently we're working on the x-axis, so we can say pick this shape here, and then we could say go to the y-axis, and we could pick this shape here. So as you can see now, we've defined two different profiles, one for the x-axis, which is, as you can see, this shape here. And we've defined another shape for the y-axis. This is the y-axis, as you can see, and for that we've used this shape here. And once we've defined them, we can actually go in and edit these shapes if needed inside here. So you don't have to stick with the original shape that we defined. We can, if we want to, add more control points, let's say, or we could edit the control points that we already have in place. We could make this, say, a little bit more extreme. Or we could make it asymmetrical, as I said. Pull that down like that. And that's basically it for that tool. I mean, if you turn on adaptive, again, you've got to be aware that where you add areas of very high curvature, you're going to get a lot of subdivisions, as you can see. That's because of the adaptive steps feature, which really does come into play when you're working with the deformations. As you can see, without it turned on, we don't really have enough geometry at this point to support this particular deformation. If we turned up the path steps, we could actually get to the point where we can support it. We can only have 100 path steps maximum. So you're never really going to get enough path steps along the length here to really support this feature. So the best thing to do is to actually just use the adaptive steps you can see here. So you can control the overall number of steps using this. But when we get to areas where we need more curvature, you can allow the adaptive system to come in and give you the extra detail that you need at those points. And all of these deformation tools can be used together. They don't have to be used in isolation like I've been using them here. So for instance, we could, let's say, just put this like this. This in here, kind of back to where it was before, really. Kind of make it symmetrical. And we could go up here and we could turn on scale. In this particular case is probably not the best thing to use at the same time as fit, because fit is a kind of scale, if you can imagine, except that we've got this basically two different curves to control the top and the bottom instead of just one, which you have in scale. So you can kind of think of fit as being like a super scale. Twist might make sense. So as you can see, we can use the deformation and twist at the same time. Theta would make sense in combination with these two as well. It just depends what kind of theta deformation you want to carry out. And you can see each one of these has its own separate interface. And so you can control each one individually, all at the same time. And if you've got a dual monitor system, then you can just pop them onto a second monitor, so you can edit them at the same time more freely. As you can see, in this case, we're only using one monitor, and we're kind of running out of screen space, really. Bevel, again, would probably make sense. As you can see, we can actually bevel it at the same time. So all of these deformation tools can be used in concert. In some cases, you might want to use scale. In some cases, you might want to use fit if you need to have more control over your object. Let's go back and look at fit in a little bit more detail. Let's see what else we have here. Actually, before we do so, let me just turn these off so you can see this, just the fit deformation in action. So you can see we have these buttons here which allow you to mirror the shape horizontally. You can mirror it vertically. In this case, it doesn't really make much difference because it's nearly symmetrical. You can rotate it, which is kind of crazy, but you can if needed. You can rotate around again, and rotate as many times as you wish, really. And then you have the option to rotate back again in the opposite direction. And you also have the option to delete control points, as you saw before. Also to delete the curve if you want to get rid of that. So we still have the Y, but we just deleted the X-axis. And also at any time, if you want to, you can go in and pick a shape again for that particular axis. So, you know, we've just deleted the shape we were using. We can just go in and pick it again, put it back in place. And the last option down here is generate path. So I'll just click on that and you'll see exactly what it does. What that does is it creates a path, which is a line, and replaces the path that you're currently using in the object. And that's just there for convenience sake, because you may find that the deformation is actually not very easy to carry out on a curvy path. So you may want to simplify the object and turn it into just a straight line, basically like an extrude. And you can do so just by clicking on that button, and that will generate the path for you. I think that's it, really. Quite a long chapter, as I said, a lot of ground to cover. It's quite a complex set of deformation tools you have there. And you can see why I actually split up the loft compound object into 3 separate chapters. It's a very complex tool, very flexible, and you can do a lot with it. And we'll even return later in this DVD to have a look at some of its features that can be used with animation, as I said earlier. It's very flexible. It does take time to learn, but it is one of the gems of 3ds Max. If you're working in architecture and you're producing, as an example, a stair rail, then you may find that the stair rail has a non-uniform profile along its length. And if you use certain tools, you may find that, you know, it's not going to be an easy thing to do. You could create a tube and then deform it and then try and bend it, but that would take a while to do. But with the loft tool, you've got the ability to define non-uniform profiles along its length. You can change the scale along its length. You can theta, twist. You can bevel at any point that you wish to. So if you're going to create complex three-dimensional curves that travel through space, the loft tool is very, very cool. It's a compound object, as we said earlier, so it has all these different elements that make it up. We've got the spine of it, which is the path, and we have the ribs, as it were. Those are the shapes. And you can change the shapes. You can animate them if you wish to as well. It's dynamic. So it's a really, really cool feature of 3ds Max and takes advantage of a lot of its architectural strengths, the procedural nature of 3ds Max. So it's definitely worth learning. And as an example, I saw on a forum just a few days ago a guy asking a question about some paving that he'd modeled. And he'd modeled the curbstones, you know, the blocks of stone that go along the edge of the pavement. And they went around a corner and went around a few blocks, some city somewhere. And he was trying to actually model, or rather change the UVs for the mapping to actually make it work along all these curbstones. And he was trying to do that with the unwrap tool. The unwrap tool is very, very cool, but it's completely unsuited to what he was trying to do, because the difficulty there is that you've got these large number of curbstones going around a corner. Each one of them would have to be unwrapped, and they wouldn't really use that much of the actual bitmap. The perfect solution for that particular scenario was to use the loft tool and to actually make the curbstones by lofting them. Then to apply, as we saw earlier in surface parameters, apply the mapping to that loft and make sure that it repeated enough along its length and also, you know, along its V and along its U, so then we got the mapping working. And then if you wanted to later, you could then collapse that set of curbstones down into a mesh, edit poly, edit mesh, and go in and edit it and make the different curbstones individual. Maybe, say, twist some of them, put in some lines, break some of them in half, make some of them a little bit smaller. But the point is that you'd have basically a mapping in place, and you'd save yourself, you know, maybe a day's work in just a few minutes. The loft tool is really a great tool for that kind of situation as well, where you have a run of objects all in a line following a curve. If you've got that kind of situation, then the loft tool is what you should really be looking at. We finish off here now with the loft compound object. We're going to move off into the next section of the DVD, where we actually go back to our go-kart project that we looked at in earlier DVDs in this series, and we'll be continuing with in the 4th DVD. What we're going to look at here is modeling some of the elements with curves, in other words with splines, as we've been looking at in this DVD. And we're going to look at certain elements of the go-kart that really only make sense modeling them using curves. You could model them another way. You could model them using polygons and primitives to a certain extent, but you're not going to get the flexibility, the speed, and the quality that you get by using a combination of the spline tools. So let's move on now and do that.